Welcome back to Hatfield's Flipped Classroom. This is Advanced Algebra 2, Chapter 12, Part 3, Multiplying Probability. Just a reminder of what we learned in the last two lessons. We learned about the counting principle and the difference between combinations and permutations, and how we can use those to actually find out how many events would happen. And then we learned about what basic probability is, and just finding the probability of certain events. Today we're going to take that one step further by figuring out what happens when there's two events. So now there are two types of events. There's independent events and dependent events. If two events, A and B, are independent, which means the first choice does not affect your second choice, such as rolling a die and pulling a card. What number you get on the die has nothing to do with which card you will pull. So there's no effect between each other, so they're independent. When they're independent, the probability of both events occurring, which is A and B, or intersection, is the probability of A times the probability of B. So we multiply our probabilities when two events happen that are independent of each other. So let's look at an example of this. In a board game, we're going to roll 3 die in order to determine the number of moves for the players. So what is the probability that if you roll a die, the first one is a 6, then the second one is a 6, and then the third die is not a 6? So the probability of rolling a 6, there's 1 6 on a 6-sided die, so it's 1 out of 6. Rolling the second die, getting again a 6, is 1 out of 6. And then rolling a third die that is not a 6, we now have options 1, 2, 3, 4, and 5 out of 6, so it's 5 out of 6. Since they are independent events, we're going to multiply them. So die 1 times die 2 times die 3. So it's 1 6 times 1 6 times 5 6, which gives us 5 out of 216. So that is our probability. 5 times out of 216 times, we should be able to get a 6, and then not a 6. So that was independent events. Well, what happens when they're dependent? A dependent event means that the first event will affect your options in the second event. We're still going to multiply. So it's probability of A times the probability of B following A, which means the probability of B given that A has already happened. So the idea is we find the probability of the first one, then we find the probability of the second one, assuming that the first one did happen. Then we multiply those two probabilities. So our example here, and we have an image in order to understand what the different types of cards are. We're going to draw 3 cards. So there are 3 events happening, and we are not replacing them. So we're not putting the card back in. That's what makes this dependent, is that when we pull a card out, there are no longer the same amount of cards in the deck because we're not putting it back in. Then we're going to find the probability of the first card drawing is a diamond. The second card we draw is a club. And then the third card we draw is another diamond. So first we have to find the probability of pulling a diamond. A diamond is a suit. There are 13 diamonds in a deck of 52 cards. So it's 13 out of 52. The second event is pulling a club. A club is another suit. So there's 13 clubs. But now there are no longer 52 cards. We've already pulled a diamond out. So now there are 51 cards. For our last event, we're pulling another diamond. Now there's 13 diamonds, but we've already pulled 1. So there's only 12 diamonds left in the deck. We've also already pulled 2 cards out, meaning there's only 50 cards in the full deck now. So it's 12 out of 50 to get our probability of the third event happening, given that the other two have already happened. Now, we multiply these three values together, and we get 2,028 divided by 132,600, which can simplify down to about 13 out of 850. So that is conditional probability, our probability of independence and dependent events, and this is multiplying probabilities. So now we're going to go ahead and try multiplying probabilities, and we're going to lead up into adding probabilities in the future. Good luck with the practice, and make sure you ask any questions.